Well, hello again everybody, and as you can see on the bench today I've got another mystery box. So this is yet another of my drunken eBay purchases that I made while I was on lockdown, and I'm afraid I bought far too many things, and the problem with buying all these things is, again, they all mount up in the hallway and my good lady falls over them and then she shouts at me. So I've got to go through some of these boxes and well, just do some unpacking. Now I've got to admit, I don't actually remember what's in this box because I purchased it quite some time ago, so it really could be anything. Now don't forget, we do like to make a game of this, so as soon as you think you know what it is, do remember to shout out and maybe leave it in a comment. Well, as you saw, that last radio that we bought was absolutely terribly packed. But looking at this one, well, we've got lots of layers of cardboard and some very heavy and substantial polystyrene blocks at the ends here. So it looks like somebody's actually spent quite a lot of time and gone to quite a lot of trouble. Yeah, for sure, they've gone to a huge amount of trouble to pack this. Look at all this packing material. Oh, we've got a cable. This cable looks quite industrial. Almost looks like something you might hang off the back of an Edison receiver or something like that. So it's got a square connector on one end and it's got this round multi-pin connector on the other. Oh, got a little box here. I say a little box. Oh, maybe not that little, it's certainly quite a weight. So what have we got in here? Put it on top so you can see it. Well, it looks like it's some form of power supply and it's very, very heavy. So it's in some kind of very thick and die-cast box. So let's just see what the warning is. Do not open before disconnecting batteries. Woodsons DF unit. Input 24 volts. Output 250 volts at 0.06 amps. So we've got some form of mains inverter here. So we've got 24 volts to 250 volts. So that's interesting. So I wonder if this is the mains input. Don't know, I'm guessing so. Come on baby, here's a money shot. Oh, look at that. Can you see that? Anyone know what it is? So I do usually start off my videos by saying I've got absolutely no idea what this is or what I'm doing, and well, that's usually because it's true, and it's especially true today. So it does say this this piece of equipment is actually made by the Woodsons, and it says it's a DF unit. So I'm guessing that DF stands for direction finding. So what I'm guessing this is, it's a direction finding unit which was used on board ship. So I'm guessing that they had some ships that were a bit like the old television detector vans in that they had the old spinning roof rack on top of them. And what you'd have some a series of land-based beacons, you know, dotted around in various places. So I'm guessing what you would probably do is you would point your antenna at one of these fixed beacons on land. That would give you one fix, and then you would go for another beacon and you would get another fix, and from those two beacon positions you could triangulate your exact position. So I'm guessing that that's what it is. It's a direction finding radio. The only other thing that I know about it at the moment is it was manufactured by this Woodsons Of Aberdeen's company, and as far as I know this company is actually still going. I think this was probably manufactured around the 1950s. It could be later, again I'm not sure. So I'm guessing we're going to find some valves inside here, but it could be later than that. Maybe we will find transistors. So I guess the starting point is well, we're not going to switch it on, let's take it apart. So I think this is going to be some kind of inverter type power supply. So yeah, let's get its underwear off and have a bit of a poke around. Is that going to come out? Oh, look at that. You know what? This could be a rotary converter. You know what? I will have a pound with you, ladies and gentlemen, that what we've got here is we've got a motor generator set. It's a rotary converter. Now, does this give us any ideas of what its power requirements are? Fuses inside. Okay, well that's a new one on me. So I've actually found one of our fuses here. So the first of our fuses is a little lathe tool. Actually, it looks as though this could be a thread cutting tool that somebody's actually used as a fuse. That's the first time I've ever seen a lathe tool used as a fuse in a radio. That's got to be a first. I can't see this fuse blowing, can you? How many hundreds of amps do we think this is? I've got no idea. So this is what they call a rotary converter. Now another name for a rotary converter is a dynamo. There's a few different names that these go by. So, but basically what it does, it takes 24 volts DC and it actually steps that up to 250 volts DC. Now a lot of people might be familiar with the alternator that you have in your automobile inside your car. Well, that is, an alternator produces AC, but actually one of these devices actually produces DC. And the way that it can produce DC is because of the design of the commutator, the way that it gets the power output from the actual motor assembly. So effectively what you've got a 24 volt motor, and then you've got on top of that motor you've got another set of windings which can actually generate the high voltage DC. Now although these do produce DC, they don't actually produce very smooth DC. So what you tend to have is got some smoothing capacitors here, but also what you've got is quite a large low frequency smoothing choke. So you can see this is a low frequency smoothing choke, and then actually we've got a separate choke here which is much finer, much smaller windings. So that's actually a high frequency choke. And then we've also got a couple of fairly meaty smoothing capacitors and another little choke there. So I can also see tucked away inside here we've got another fuse, so I'm guessing that this must be the high voltage, the HT fusing. So as you saw, this dynamotor assembly is actually designed to power a ship's radio, but you'll actually also quite commonly find these in aircraft assemblies as well for aeroplane radios. So I can also see, looking at this capacitor, I can see that it also appears to have got a little pot mark in it, so it's obviously vented, so this capacitor probably needs replacing as well. But looking at the two fuse holders, I can see that only the actual top fuse holder here has actually got wires going to it, so that's just to hold the spare fuse. Now I'm suspecting this probably needs quite a hefty fuse in it, so maybe I'll choose something like 5 amps to start with. In fact, I'm going to put a bigger one still, and I'm going to put a 10 amp fuse in it, because what we'll do is I'll use my current limit on my power supply. So I'm guessing these front connectors here must just be very simply the actual 24 volt input. Yeah, I think maybe this one is actually the earth, and maybe this one is the plus 24 volts. Oh, I can hear a motor running. Ooh, some lovely sparkies there. Don't worry, I'm a trained professional. Oh, that sounds a bit better. It seems to like being in this orientation better. 19 volts. Ah, there we go, 388 volts. So there she blows, we've got 388 volts. Of course that's unloaded. So as usual, I've got no idea what I'm doing, but that isn't going to stop me just plugging everything in and, well, let's just give it a try. Now, does it matter which way this plug goes up? Is it coded in any way? So it will certainly go in that way up. But it won't go in that way up. Yeah, okay, so there is some coding on the pins there. So I'm guessing that this now has to plug into here because that's where it fits. Now unfortunately I can't plug this connector into here because I can see that somebody has put some big blobs of solder on the end of these connection pins, so I'm going to have to get that off first before we can do another test. And we'll give our mating connector a bit of a spray. Let's see if this will go together now, fingers crossed. Now obviously the correct thing to do would be actually to open this up before we put power on it and just check that everything's okay. Of course I'm not going to do that, let's just power it up and see what happens. Oh, we have light! Well, turned everything off because we have smoke, Well, I did tell you we should actually open this up and have a look before switching it on, didn't I? But you wouldn't have it. Well, I don't know where the smoke was coming from, but I can see one of the problems in that maybe why this wasn't working, because we've actually got a valve missing. So there should be a valve base here, or a valve installed. This valve's red hot. This valve's red hot, this valve base is missing. The question is, what was smoking? I suspect what could have been smoking was this electrolytic capacitor here. First thing I've put my finger on, and this electrolytic is red hot. Is anything else getting hot? Let's just have a quick poke around inside. That's cold, that's cold, that's cold, that's cold. Cold, 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 cold. Okay, everything is cold apart from what I'm guessing is the main smoothing electrolytic on top here, which just got hot. Now the only problem is, of course, I think I might have to do some reverse engineering now, because I've got absolutely no idea what the valve is that we're missing, because I've got no circuit diagrams for this, so it looks like I'm going to have to do some digging round. And we've also just spotted another couple of valves over here at this end. So we've got an EF85, an ECC31. Can't quite work out what that is. It looks as though it could be EBP something 30. Not sure, because we don't know if any of these valves are correct or even in the right locations. And then we've got a 6BW6. Is that an output valve, a 6BW6? I'm not exactly sure. I'm afraid I'm rubbish at valve names. So I think this is kind of the point that I probably need to just stop at now and see if anybody on the whole of the World Wide Web can tell me anything more about this unit. Tell you what, just for a giggle, shall we just snip out this capacitor and give it a quick test? Okay, it's measuring 200k and climbing. Maybe it's one of them jobs that actually just needed a little bit of time to reform, but I don't have a lot of faith in reforming capacitors. My opinion is if they're going, they are going. Let's have another go. So we've got a crackle and a pop. Oh, we've got smoke again. Where's the smoke coming from? Lots of smoke. Come on, where are you coming from, smoke? Ow! Jesus! Okay, we've got a very, very toasty capacitor in there. So I think it's a capacitor that's getting hot. Ow, yes, we've got a very, very melty hot capacitor in here. Unfortunately, it's behind this this connector here, so it might be a little bit hard to see it. Oh, I wonder if it could be a cathode bypass resistor, capacitor. Although maybe it's not big enough for a cathode bypass. Whatever it is was running stinking hot. It could be a cathode bypass, couldn't it? Because it is going to this valve base here. So I wonder if this valve here, maybe that's the output valve and it's got some DC on it and it's red plating. I don't know. So these are all branded TCC capacitors, and I think generally these are well known for going bad. So it's hardly surprising. Okay, so we've got another capacitor that needs sorting out there. So I think it's definitely time to stop at this point. It looks as though the entire radio probably does need recapping, but before we plunge in and do that, it would be nice to find some service data, wouldn't it? So I'm going to go away, see if I can find said service data. Don't hold out much hope, but we will see if we can find some. Now unfortunately I haven't managed to find any data on this set, no circuit diagrams or anything like that, and unfortunately I will be the first to admit that my abilities aren't amazing when it comes to valve radios, and if I don't have a circuit diagram, unless it's a simple fault, I do tend to struggle to repair these things. I'm not super experienced, but on the basis that, you know, at the moment it doesn't work, we can't actually make it work any less because it doesn't work at all. We may as well have a go at the repair. So the first thing I've got to do is I'm just taking off the this mains connector here on one side, not the mains connector, the DC power connector, because unfortunately I can't get the soldering iron in to actually take this old defective capacitor out. I just can't get at it. Unfortunately, a lot of this chassis all appears to be riveted together. There is some screws in it as well, but it's also got a lot of rivets in it, so it's not the easiest thing to work on. Now I'm a little bit dubious at touching these because they seem to have oil leaking out of them, and well, I'm not exactly sure what this oil is. A lot of these capacitors were, I think, like paper, but they were oil filled, and I'm always a little bit cautious working on these because some of the oils that they filled these with were notorious for being highly cancerogenic, and yeah, that's a little bit of a worry. So looking at this capacitor, I actually thought it was a paper capacitor, but it is actually an electrolytic. It's got little positive symbols at one side, and it says it's a 25 volt working 10 microfarad. So I'm wondering what voltage that was seeing across it. Okay, so it's coming up as 3.6 microfarad with an ESR of 1.5 ohm. So that doesn't sound right to me. So yeah, it's definitely not good. Well, I'm afraid I'm not sure how well it will come out on camera, but I've been having a poke around inside, and I found the source of the smokage in that we had a cathode bypass resistor and also a capacitor down here. I'm kind of pointing at it right now, and I've gone ahead and changed them out because the actual cathode bypass resistor should have been 1K, and that measured as 4K. Now obviously that's gone high by 4 times the amount, so that needed changing out. But it also, the capacitor that it had adjacent to it, that would also gone short circuit as well. So yeah, some funkiness had gone on down there. Now it could be that both of those components were actually killed by the fact that there was something wrong with this grid coupling capacitor, because funnily enough I always warn everybody never just to switch a valve set on. You've always got to change the grid coupling capacitors. Well, you know, I didn't follow my own advice today. Do as I say, not as I do. And that could be one of the reasons that perhaps why I've toasted these components, because the valve was maybe just conducting very, very heavily, because this one was measuring 2 megohms, whereas again that's not exactly a very low resistance, 2 megohms, but really these things want to be measuring as infinite. So again, we've changed out the grid coupling capacitor. Now I have to say I'm actually also very suspicious of our power supply here, because I seem to be getting higher voltages out of it than I was expecting. So I believe that, well, certainly on the front here it was saying 250 volts at 0.06 milliamps. Well, I think when I fired this up earlier I was getting not far off 500 volts, which is probably why some of the electrolytics croaked it. Now the other thing is the valve filaments are the 6.3 volt heaters in these valves, and Well, again, when I powered it up on these off this power supply, I noticed that the actual, not the filaments, but I could see this has got some lamps, some dial lamps on it. Now those dial lamps look too bright. Now a lot of the valve arrangements, what they've actually done is for every pair of valves, they've actually paralleled them up to actually give 6.3 volts across each valve, and I think that's designed to then work from maybe a 12 volt supply. But from what I can tell, if you put 24 volts out, if you put 24 volts into this power supply, you get 24 volts out of it that supplies one of the heaters. But so I think there's some shenanigans going on there. But the other thing I've noticed is we've got a couple of wire links that I don't think are original between this green wire and this yellow wire. Again, I haven't traced these out yet, but I think there's a link in there, so maybe this link is causing a problem. I'm not sure. We're going to have to investigate that separately. So what I'm going to do is I'm just going to run the radio off a separate power supply, and we'll look at this later. So there we go, we've got 250 volts on it now, and if I actually just go ahead, I'm just going to prod one of the coupling capacitors, which is that one. So you can actually hear we're getting some audio crackling, so certainly it does appear that our audio output pentode valve is working. Now before that, I don't have the correct circuit diagram for this, so I'm working to a circuit diagram from another radio. I've checked a little bit of the circuit out, and from what I can tell it does seem to be conforming to the other circuit diagram, but well, it could still be completely wrong. It could be a completely different radio altogether, that. So I'm still trying to discover what the missing valve is. I think it's probably some form of like audio preamplifier, in that it's a double triode section, but I'm not exactly sure, so I've got a bit more tracking down to do there. So while I'm trying to work out what my missing valve is, I think we're going to go back and have another look at this rotary converter just to see if we can work out if it is giving off the right output voltage or not. So I can see that one of the wires here, it's got a wire link on it, so I'm going to assume that that is the ground. I'm going to use that for grounding my voltmeter to the chassis. Now I don't know if it'll come out very well, but somebody has installed a wire link here between the green and the yellow wires, and well, let's test it with that link in place first and see what we measure. Okay, so there may be some sparkage. So certainly on one of the outputs here we've got around 485 volts, and on the other outputs we seem to have 19 volts. For what it's worth, I think I'm just going to try unsoldering this link here, because I don't think this link is a factory original. I think it's maybe one that's been bodged in, but I'm not certain. So that link was between yellow and green, so just remember that in case we decide to put that back later. Yellow and green. I can't see that this power supply would be capable of producing a 12 volt output. Let's put the power on again and see what happens. Ah, well, nothing happens, so it looks to me like the only purpose of that link is it's some form of on and off switch. Let's just verify that. So that does appear to be some form of on and off switch, that. So it does look as though this does deliver 24 volts to this radio, which is too high, 24 volts, and it also delivers 500 volts of DC, which again is too high. Now it's possible that that 500 volts will be pulled down significantly when the radio is actually running. That's certainly a possibility, but I don't know, it just seems very high, that, doesn't it, 500 volts. So I've actually been taking a little bit of time just to go through the valve lineup, and particularly to see how the filaments are wired. So if we look at the two valves here, I think one of these is It might be something like an RF amplifier. I think the other one is the mixer valve. Not sure which way around they are, but basically if we look at the heaters for these two valves, we've got two 6.3 volt heaters and they are wired in series with each other to provide a 12 volt combination. And at the opposite side of the receiver we've got a couple more valves here. There's the audio output valve, and again these two valves, they've got their filaments, they're both 6.3 volts. They're connected in series with each other, and again that series combination is actually connected directly across the low tension supply. But here we come to our missing valve here. This is, again, it's got its filaments connected to pins 4 and 5, but interestingly enough this valve has got its actual filaments connected across the low tension supply, so it isn't in series with any other valve. So the heater on this valve sees a full 12 volts. So I'm kind of thinking that I was actually supplying this radio with 20 volts before. Now the reason I was supplying it with 20 volts is because I wanted to supply it with 24, but my power supply only goes up to 20 volts, a higher current one. And the reason that I was supplying it with 24 volts is because the front of the power supply says that it's got a 24 volt input 24 volts. So I actually think it's quite telling that this valve V8, it's got a different voltage heater than all the others. Now that might be quite useful to actually help to identify what this particular valve is, because that is one of the next jobs. But certainly I think that I'd been supplying this radio with too high a voltage, and because I've been supplying it with double the voltage, input voltage, I've also been supplying the actual rotary converter, the dynamo, to too much voltage. So that's probably why we're getting close to 500 volts when we should actually be getting 250. So what I've done is I've actually gone ahead and I've reset my power supply to 12 volts, and I've checked the voltages now across each of these filaments, and it's now bang on about 6.3 volts. So yeah, some real shenanigans there, but I guess it's a test to show how resilient valve stuff is, because all the valves are still functioning, we haven't burnt anything out. But it probably explains why I blew up this electrolytic to start with, and probably why the cathode bypass resistor and capacitor died previously, because I was feeding too much voltage into this radio. So yeah, stupid me. Now I said earlier that I didn't manage to find a circuit diagram for this particular radio. Well, that's actually true. I haven't managed to find a circuit diagram for this model, but I've actually found a circuit diagram which I think is quite close. Now this actual circuit diagram is one that I've cut down and rearranged a little bit to suit, but it originally came from a slightly different set, which was a radio telephone, which was also made by Woodsons of Aberdeen as well. As much as I've checked it out so far, it seems to match fairly well. Now, because the circuit diagram doesn't actually tell me what type of valve this is, the only thing that I've actually got to go on is the picture here, which does show a double triode arrangement. You can see the two separate sections of the triode there. And the other thing that we found out is that it has a 12 volt heater, and again that helps narrow it down. So we're looking for a valve that's a double triode with a 12 volt heater. So actually all I did was I've just done a Google search, and the valve that actually comes up is the ECC80 series. So that would be an ECC80, 81 and 82. So taking a look through my valve collections, the only valves that I could find are here. So this is the first one I found, which is an ECC84. Well, this has actually got the wrong heater configuration. This is the 6.3 volt heater. So we put that on one side because that was no good. And then the other two valves that I managed to find was this ECC81 and also the ECC82. So taking a look at the ECC81, certainly it has two 6.3 volt filament heaters. Now you can connect them in series with each other to make 12 volts, or you could probably parallel them up to run it off 6.3. But take a look at this valve, you can see it's actually gone white. It's gone to air. So this valve is no good because it must have a crack in it somewhere and the air has leaked into it, and that's why it looks this like it's got this white milky colour. So unfortunately there's nothing we can do with this valve apart from throw it away. I can only assume it must have got damaged in storage somehow, because I can actually see it's got a crack across the bottom of the base, so air's leaked into it. That's no good. So the only other valve that I've actually got in stock, which again has got this 12 volt heater arrangement, is an ECC82. Now I've got to admit I'm not exactly sure what the difference is between the EC81 and the 82, but I've had a look at the pinouts, Now the pinouts do appear to match what is on our diagram for our radio, even though it's a wrong radio. The pinouts do match, and I've spent a little bit of time again belling out the connections on the valve holders, and they do seem to be appropriate for this ECC82 valve. So I think all I can say is beggars can't be choosers. I just happen to have this ECC82. It's the only one I've got that's suitable, so yeah, we're going to have to use it. So I'm just making doubly sure that this doesn't get switched on to 24 volts on here. Looking at the label very carefully on here, it says 124, and for some reason I read that as input 124 volts. Now I'm just wondering if the idea was maybe you should have blacked out some of these numbers to actually say what voltage it is. It's just not clear at all. Input 124. So does that mean it's an input 12 volts or 24 volts? Well, I certainly got it wrong, so I'm just going to scribble out the 4 bit. So now it says input 12, and then what I'm going to do is I'm going to put a separate label on here just to make it very clear that the input to this power supply should be 12 volts. Okay, so the next thing that I found is now we've actually removed that wire link, because you remember we had a wire link that was across a couple of pins of the dynamo to supply here. We've removed those pins now, and now we find when we switch the radio on and off, it actually remotely starts up the dynamo. So let's show you that. So let's switch the radio on and see if we can tune anything in. Fingers crossed. Can't hear anything yet. Oh, can you hear that? The motor's slowing down, so it's loading the HT rail up. Come on, anything. Fingers crossed. Is it going to work?
McTominay brings it up to the edge of the area, pokes it to his right, finds Greenwood. Greenwood can't get that cross in. Alioski blocks it into the last minute of added time. Leeds 0, Manchester United 0. Manchester United will be 2 games away from completing an unbeaten season away from home. Wan-Bissaka's ball onto the chest of Cavani. Too hard, couldn't control it. Alioski, all clearance is blocked by Fernandez. Next one, McTominay blocks. Leeds are just panicking a little at the back here. Van de Beek onto it, just trying to stab it through for Cavani. Couldn't find him. And then just a wild swing from Llorente. Clears it with his right foot.
Well, certainly, if you can actually hear anything above this dyno motor, the radio is actually working. So we're on band 2 at the moment, which is between 600 and 1.5 megahertz. Let's do a band sweep. Let's turn to the beginning of the band to 600 kilohertz. You can certainly hear the noise from the motor, can't you? Can you hear it there? Let's picking it up.
Heroically here, and it's finished goalless. Leeds United 0, Manchester United 0. Marcelo Bielsa reaction like he's run. From stars at number 2. Before that, Urban Hymns. Still penalty areas, and then we just didn't get that moment of quality. Some tough tackles. Shoulders a bit for a second. The top clubs, the top 7 or 8 clubs.
I'm hoping you can see we've got this switch here which is marked PIM, P-I-M. Now I believe that this switch is actually used when you're trying to use the radio in its direction finding mode, so I'm guessing that would be used with some form of rotating loop antenna that would be on top of the ship. Now I explained earlier you could probably use this to get fixes on navigational beacons. Now those haven't been used for many years because we have things like GPS now. But the way I think it works is when you actually put this radio into its PIM mode I think it takes the audio output from the speaker, it rectifies it and it applies it to this milliamp meter. So what it's actually giving you is signal strength, so you could see the signal strength, and it's used as a tuning indicator when you're tuning into those navigational beacons. Now the other thing that I think it does, it also turns the gain of the radio to maximum. I think it defeats the automatic volume control, so it sets the radio to have maximum sensitivity, so you can ensure that you can pick up these navigation beacons. So let's just switch this PIM control on, and hopefully we should see this meter move.
Left hand from the Frenchman, and he's pushed it away and out for a corner. From the Manchester City fans, and even that slow flutter of applause is a welcome sound. Like Wembley Stadium will have 8,000 fans, 4,000 of them have come from Eden. Carabao Cup final, the first final of the season, thankfully with fans.
Living with type 1 diabetes can be frustrating.
Most players will be really buoyed by the fact that he's made the team. But was outstanding last season, one of the best defenders in the Premier League.
So I'm going to count that as quite a big success. I'm just going to say there was no skill involved there. We just got very, very lucky that I didn't damage this receiver, and we also just got lucky with this double triode valve, because just what I happened to have in stock. Now I'm sure that this radio probably needs quite a bit more work on it, although I've got to admit it seems to be working very, very well. It's a very, very lively receiving set. It would probably be quite a nice project to try to make an actual proper loop antenna for it, because at the moment I've just got it connected to my long wire. Now the only other thing to say is it's got a lot of these capacitors in it. I think they've got the name on it, something like Metal Mite or something like that. And I may have said earlier, I hope I did say, those capacitors are absolutely terrible. Really, they probably all want replacing, and if this was a radio that I was going to use a lot, I would go ahead and I would replace all these capacitors, even though this isn't the particularly easy set to work on. But I'm not going to do that, because this set isn't going to get used very often. I think the fact that you've got to have the motor generator running really just makes it not usable. You wouldn't want to sit in a room and have that generator running. It's just far too noisy and distracting. Even when it's installed in its box, it's still far too noisy. I'm sure you wouldn't notice it in a ship with the noise of the engine and waves crashing onto the decks, but yeah, it's not the sort of thing you want to listen to. But I actually think this radio is special enough and unique enough that I don't want to mess with it. Although I do like all my radios to work. Well, you can see this radio certainly does work. I think there is a case for keeping this original, because I've never seen another radio like this, and I'm not sure that there's any more left in existence anywhere. So I think it's better not to mess with it too much. We've got it functioning, we've got it receiving, it can be brought out on special occasions and used, but it's certainly not going to be a set that I'm going to use every day. But certainly I am just really pleased that we were able to actually get this radio functioning again. So what I think I will do off camera, I'm going to give it all a bit of a clean. I'm going to change out maybe some of the electrolytics and restuff some of the electrolytics in the dynamotor supply, because I can see that a couple of them have gone bulgy. But I think that's all I'm going to do on that, and then we're going to call it done. So I think for today we've probably reached a natural conclusion to this video and a good place to finish. So until next time, as always, thanks very much for watching, but until then, bye bye for now.